We're at go2math.com, working some calculus, go to area, and go to math. Anyway, we're at 8.2. We can click there, or we could actually just click on the button here, however you want to do that. And I did add a button to this, I should say. Just click on that and it brings up that problem set again. How nifty is that? So we've got the, what do we have? We've got the integral from pi thirds to 4 pi thirds of cosine x dx. Now this is the setup to integrate from let's say pi thirds to 4 pi thirds. However, when we're finding the area, we got to do some additional things. For example, look at this. We're going to end up getting a negative number here, a negative number. So that means that if we're going to get a negative number, we got to take this area right here and multiply it by -1, make it positive, take the absolute value, do something like that. So, you know, that actual integral, the initial integral, is not going to be our actual answer to finding the area, right? If we actually just calculated this up here, that would be completely wrong. So that's the reason we need to understand what it means to be finding the area, right? So we're going to find this area, and then we're going to find this area, of course, then multiply it by -1. Now the question is, what is this, right? What is going on here? Where does it stop? So we need to find this area first, and then go from here to here. So we're working with cosine, and when is cosine 0, right? Well, cosine 0 when x is 0, right? And cosine's also 0 when we're at pi halves. When we're at pi halves, is that right? No, 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 I got that wrong. Cosine, that is not 0. Oh my God, I need to go back to bed. That's actually 1, right? Cosine's 1. At pi halves and 3 pi halves. See this? This would be pi halves, 3 pi halves. That's when cosine's 0. Anyway, did anybody write that down, or am I the only one out there talking to myself? Let's go bring up the whiteboard. I am tired. This stuff is exhausting. I don't know what's going on with that. So we got pi thirds, 4 pi thirds, and cosine x dx. Of course, you know, this is not really what we're trying to find here, okay? Alright, so we're going to break this up. We're going from pi thirds to pi halves, remember? And it's cosine of x dx. So that's going to be one of them. And then we're going to, what are we going to do? Let's just do it down here. Now, there's a couple ways you can do this. You can flip these guys, or you can just multiply through by a negative. We'll just do that. So we're going from pi halves to 4 pi thirds. 4 pi thirds of cosine x dx. So let's just go ahead and get this one. Well, the integral of cosine is sine. And we're going from pi thirds to pi halves. Right, let's just do that. So we plug this in, we got sine of pi halves minus sine of pi thirds. Alright, so the sine of pi halves, well, pi halves is up here, and sine is your y. So that looks like that's just going to be 1, right? We're working with the unit circle here. Now, remember, there's 3 values you need to remember here. Usually I write square root of 2 over 2 in the middle, but okay, so remember that square root of 3 over 2 is bigger than a half. Okay, that's what you got to remember. Square root 3 over 2 is greater than a half. Okay, don't worry about this. This is the 45-degree angle one here. Okay, now, this is what we need to remember. This guy right here. So we already got that figured out. Pi thirds, and something else you need to remember. Pi thirds is 60 degrees. Okay, it's equivalent to saying 60 degrees. This is radians, that's degrees obviously. So it's 60 degrees, pi thirds is 60 degrees. Okay, so if we got a line at 60, we're coming down like this. You can see that this side right here is shorter than this side, right? Shorter than this side here. We're talking about sine. We're talking about the y coordinate. So we're talking about this distance right here. All right. So that means that this has to be the square root of 3 over 2. That would be this distance. And then this has to be a half. Okay. And of course, what are we working with? Sine, that's your y. So that would be this side right here. Okay. Okay. Trying to reason through all that. So the sine of pi thirds is the square root of 3 over 2. It's that simple. It's really that simple. So let's look at this one here. Wait a minute. Are we done? Yeah, we're done. Okay, so we got the minus. We're going to leave that minus outside for a while. Okay, it's not invited. Go ahead. We got cosine. No. Ooh, take the integral of cosine, you get sine. What am I talking about? Sine, getting ahead of myself or something like that. So we have sine of 4 pi thirds minus the sine of pi halves. Okay, now remember we got this minus sign out here. Alright, well let's look at this. Sine of 4 pi thirds. Okay, so if this is 60 degrees, so this is a pi thirds, a pi thirds, a pi thirds, right? And then of course this is going to be, so we have 1 pi third, 2 pi thirds, 3 pi thirds, and 4 pi thirds. We're down here, right? We're down here. And remember that it is, I needed to make this a little steeper. Wow. Okay, so this side right here is greater than this side here. Okay. All right. Anyway, um, it's going to be the square root of 3 over 2, but the question is it positive or negative? And because we're down in this quadrant and it's a y coordinate, it's going to be negative. So that's what you got to remember. Okay, so we have negative square root of 3 over 2, and then we have minus and sine of pi halves. Now sine of pi halves is going to be, this is pi halves right here, and that's just going to be 1, right? Because that's your y value. We're up here. All right, so that's just going to be 1. Okay, and then of course we distribute this, what are we doing? We are, ooh, I said it was negative and I didn't write a negative sign. There's supposed to be a negative in there. Okay, so we have this negative outside, negative square root of 3 over 2. Negative negative makes that positive, and then we distribute this across, and that makes that a positive 1. So we end up with the square root of 3 over 2 plus 1. Okay. Alright, so did we get both of our areas here? We got this area plus this area. Now here's something interesting. We've got 1 minus the square root of 3 over 2 plus the square root of 3 over 2 plus 1. Now that's nice because those guys cancel out and we're left with a 2. Are you kidding me? We're left with a 2. Could it be that easy? The answer to the universe was a 2. And it is. Wow, that's amazing. And of course JavaScript throws this 0 on here. I'm not going to argue. Let's not argue about it. Round to 2 decimal places if needed is what I should say here. I could probably fix that. I'm not sure. Anyway, so that takes care of all the problems in this section until I decide to add more, until I get caught up with calculus, algebra, and trigonometry, finite, statistics, differential equations, discrete math, abstract algebra, calculus 1 and 2, that's advanced, and real analysis. And when I get caught up with all those, I'll add some more problems. I'm just kidding. Anyway, did I leave out any math courses? I'm not sure. Well, that's where we're at, and you can come on back to go to math.com, and maybe I'll see you there.